So today we're going to look at real numbers. So a real number is a value that is a measurable distance on a number line. Most numbers you think of are real, and then our real numbers have lots of subcategories. So let's look at our subcategories. So I'm going to start on the very interior right here. Natural numbers. Natural numbers are what we call counting numbers, the things you learn to count with. So 1, 2, 3, 4, so on. Then, after you left kindergarten and went to like first grade maybe, you learned that there was another number called 0. So, whole numbers are my counting numbers, and 0. So now we know that when we count, we go 0, 1, 2, 3, and so on. Then, you kept going on in school and you learned about a thing called negative numbers. So integers are my whole numbers plus negatives. So it's really plus or minus my whole numbers. So I have positive whole numbers and negative whole numbers making up my integers. And then finally, we have rational numbers. So we take our whole numbers. Rationals are also fractions or decimals that terminate. So my rational numbers includes my counting numbers, my whole numbers, my integers, and on top of all of those things, so I'm going to do integers and fractions and terminating decimals. So if I can write a decimal that ends like 0.5, 0.016, terminating decimals. Now over here on the other side, we have irrational numbers. And irrational numbers are numbers, they're real, they just don't have a terminating decimal. So they have no fractional form. They might have a fraction approximation, but not an approximation. I mean the exact same value. And then they never end. So it's no fractional form and never ending decimal. Never ending decimal that doesn't repeat. And what I mean by that is the decimal point 33333, it never ends, but we can write that as 0.3, and then we write that as 1/3. And then because it has a fraction approximation, this would fall into the rational category, not the irrational. So if I have a number, a square root of 2, that it never has a terminating decimal, then it is irrational. Pi, e, all of those things. And then when you take all of the rationals with all of the irrationals into one big family, those are known as our real numbers. Remember, a natural number is a whole number is an integer is a rational number. So if I have a natural number, it's also a whole number, it's also an integer, and it's also a rational number, and it's also a real number. So just keep that in mind. Let's try classifying some numbers. So we're going to take the given numbers, and we are going to classify them. Now keep in mind, just because you put it in one category doesn't mean you're done. Because if I go back real quick, so if I go right here, -8. We're going to start at the beginning of the list. -8 is not a natural number because it's negative. It's not a whole number because it's negative. But -8 is an integer. It is a rational number. It terminates. It's not irrational. And it's also real. Then I'm going to do -6. -6 also, same idea. Okay, this one's a little bit tricky. This one right here, I can rewrite that as -3. Making it fall in the same categories. It's an integer, it's negative. It's a negative whole number, it's rational, and it's real. -3/4, that's a fraction. It's not an integer. It's not a natural number, it's not a whole number, it's not an integer. It is, however, a rational number and a real number. 0. 0 is not a natural number. Remember, natural numbers were our counting numbers, 1, 2, 3, 4, but whole numbers started at 0, so this is a whole number, and whole numbers are integers. Integers are rational numbers. Rational numbers are real numbers. 3/8. 3/8, that's a fraction, so we know it's rational. And it's real. 1/2, same idea. It's rational and it's real. 1, the number 1. 1 is a natural number. Remember, that's where we start counting. 1, 2, 3. So 1, natural numbers are whole numbers. Whole numbers are integers. Integers are rationals, and rationals are reals. Square root of 2 and square root of 5. Those were in the other side of the reals. They are irrationals. They don't have a terminating decimal. So square root of 2 goes here. Square root of 5 goes here. They're both irrational. But just because I'm irrational, I'm still real, because rationals and irrationals make up all the reals. And then 6. 6 is a natural number. It's a whole number. It's an integer. It's a rational. It's not irrational. And it's real. So if we go down, the next example asks us y is 1/3 a rational number, but square root of 5 is irrational. They both have decimals that continue on forever. Well, I alluded to this earlier. Even though 1/3 is a decimal, which is 0.3333 forever, it has this fractional form. And that's really the difference, is that if I can rewrite something as a fraction or without a repeating decimal forever, then I become rational over irrational. So 1/3 is rational because, hang on, I'll write although. Although it is not a terminating decimal, it has a fraction equivalent. Root 5 is a non-terminating and even non-repeating with no fraction equivalent. Thus making root 5 irrational and 1/3 is rational. So let's work at some basic math that we've always looked at. So we have some common notation operations. So this whole thing right here is known as an exponential expression. The a is known as the base, and the n up here is the exponent. So right here, 2 to the 3rd means I'm going to have 2 3 times multiplied together. 2 times 2 times 2. And 2 times 2 times 2 is 8. So let's try evaluating some of these. We're not just going to throw them in a calculator. We're going to show work because you're going to need to be able to show work and explain your rationale. So 4 to the 3rd means that we take 4, 3 times. Oh my gosh, sorry, struggling to write the right number. So 4 times 4 times 4, okay? Pieces, 4 times 4 is 16, times 4, this is 64. The next one, be a little bit careful. So this says that we're going to do negative 6 squared, but that negative 6 is in parentheses, so we're going to do negative 6 times negative 6. A negative times a negative makes a positive, and 6 times 6 makes 36. Letter C is different than letter B. So the negative's on the outside. So what this says is negative, and then we do 6 squared, because the square right here is only on the 6, not the negative. So then we do 6 times 6. So the negative drops down. 6 times 6 is 36. So in this case, the answer is negative 36. So be careful that you are watching what's going on. This says 4 times. The 3 is the only thing that is squared. So we do 3 2 times. 3 times 3 is 9, times 4. 4 times 9 is 36. This last one's different than letter D, so be careful. The square on the outside is on the whole quantity. So, this equals 4 times 3 twice. 4 times 3. 4 times 3 is 12. 4 times 3 is 12. 12 times 12 is 144. So let's go back and review what's called order of operations, which you frequently called PEMDAS. So before we review the rules, let's write down PEMDAS, but I'm going to write it a little bit differently. So when we do PEMDAS, we do parentheses, exponents, and then we multiply and divide. Same time, multiply and divide. One is not more important than the other. And then it says it right here, from left to right. And this is add and subtract. From left to right. We have to work in order. So some hints or some things they tell you. Step 1 is to make sure that you treat the fraction bar on top, the numerator and the denominator separately. Like work in those things first before you do anything across the fraction bar. And then use the rules of parentheses or square brackets. So make sure that you do your parentheses and your brackets, then your exponents, and then work your way through. And one thing under exponents, powers, and roots. You should have learned in Algebra 2 that a root can be rewritten as a power. So roots fall with the exponents because we can write a root as an exponent or an exponential form. So let's try. So if I do letter A, we're going to do PEMDAS. So the first thing I'm going to do is I'm going to do my exponents. So I'm going to do first is 2 cubed. It means 2 times 2 times 2. So 2 times 2 is 4 times 2 is 8. So then I have 6 divided by 3 plus 5 times 8. So remember, it said to multiply and divide from left to right. Neither one is more important than the other. So as I move across the equation, 6 divided by 3 is 2. I don't add yet because that's not in this step, but then I do have to do multiply. 8 times 5 is 40. And now all I'm left to do is my adding. So my final answer is 42. Letter B. I have grouping symbols this time. I have parentheses, so I have to first do my parentheses. 14. Once you do what's in the parentheses, you can drop the parentheses. You don't need them anymore. Divided by 7 times 3 minus 6. So from left to right, we're going to multiply and divide. So when I divide, divide here, 14 divided by 7 is 2. Still have times 3 minus 6. Then I have to multiply. So I'm going to get 6 minus 6, and then 6 minus 6 is 0. Letter C is a fraction bar, so remember, we're going to work in top and the bottom of the fraction bar, the numerator and the denominator, before we move to crossing the fraction bar. So if I do this, on top, the numerator, I have 4 plus, I have an exponent. So 3 squared is 3 times 3, which is 9. On the bottom, you have to multiply first. So you're going to do 6 minus 5 times 3 is 15. Then, in the numerator, I'm going to add. So on the top, I get 13. 4 plus 9 is 13. And in the bottom, 6 minus 15 is negative 9. 13 is a prime number, so I cannot reduce this fraction at all. So I don't even need to cross the fraction bar and do anything. That's my final answer. Okay, we're going to do fraction bar again. So I'm going to have negative, oops. So I just want to take note of this right here. This says negative 3 times negative 3. Negative 3 times negative 3. And then one more time, it's to the third times negative 3. A negative times a negative is a positive 9. But then I still have times a negative 3. So this is going to make a negative 27. So I have this negative out front. Right here. Don't forget about this negative right there. So I have negative, and then I have a negative 27 plus a negative 5. In the bottom, I have no exponent, so I can go ahead and multiply. 2 times negative 8 is negative 16. And then minus 5 times 3 is 15. Okay, negative negative makes this a positive 27 plus negative 5 over negative 16 minus 15. 27 plus negative 5, aka 27 minus 5, is 22. Negative 16 minus 15 more is a more negative. It's a negative 31. Okay, for these ones, we are going to be very careful. So I'm going to go ahead and write this down, and then I'm going to plug things in. So I'm just going to write down negative 4, and then every time I see a variable, I'm going to put parentheses. This is how you should always plug values in. Negative 7, parentheses, plus 4, and then parentheses. So this was an x, and x became a negative 2, so in here I put my negative 2. This was a y. The y is a 5. This is a z, the z right here, negative 3. So now I can do my PEMDAS that I was doing in the previous problems. So negative 4 stays out front. This is a negative 2 times a negative 2, which makes this a 4 minus 7 times 5 plus 4 times negative 3. Now all of these are multiplying, so I can go ahead and do that multiplying step. Negative 4 times 4 is negative 16, minus 5 times 7 is 35. And then 4 times, this is a negative 3. 4 times negative 3 is a negative 12. So since they're all negative, we can add them up and then just make them negative, or you can go ahead and do 16 minus 35 minus 12. It is the same thing, but either way you should get negative 63. So I'm going to write down letter B, and remember I'm going to put parentheses in for what I need to plug in. So I have 2, and then I have the big parentheses that were there, and the minus 5 and the squared, but then I need to put parentheses right here to plug something in, plus 4 times parentheses over something plus 4. So the first one was an x, so this should be a negative 2. The next one was a y, so it's a 5. And the bottom one should be a z, which is a negative 3. Okay, so let's clean this up. I'll draw a little dotted line so we have some space. Okay, so I have 2. I need to do inside the parentheses first. So negative 2 minus 5 is a negative 7 squared plus 4 times 5 all over negative 3 plus 4. Okay, so this thing right here is a negative 7 times a negative 7, which makes a positive 49. So I'm going to have 2 times 49 plus 4 times 5 all over negative 3 plus 4. Okay, and then I'm going to do 2 times 40, well, actually, hang on. 2 times 49 is, that is going to be 98 plus 20 all over 1. So this is going to end up being 118. Okay, this last one. Don't be afraid of the fractions. So I'm going to get something over 2 minus something over 5 over 3 times something over 9 plus 8 times something over 5. So all of my x's were negative 2's. All of my y's were 5's. And this time I had 2 5's. Oops, I wrote a y there. And my z was negative 3. I always reduce fractions, so let's see if we can't clean this up a little bit. So I'm going to get negative 2 divided by 2 on top is going to be a negative 1. Minus 5 divided by 5 is 1. Over, I'm going to get negative 9 over 9 plus, I'm going to multiply my 8 by 5, and then I'm going to divide by 5. So I can just undo both those. Or 8 times 5 is 40, divided by 5 is just 8 again. And then also this piece right here, negative 9 divided by 9 is just a negative 1. So if I rewrite this one time, I get negative 1, I get negative 1 minus 1 on top, negative 1 plus 8 on bottom. Negative 1 minus 1 is negative 2. Negative 1 plus 8 is 7. And there's your answer. So on the next page, you have a bunch of properties of real numbers. Go through these. So closure property just means that a plus b is a real, if a plus b is a real number, a times b is going to be a real number, because up here, a, b, and c were real numbers to start with. So adding a real plus a real or multiplying a real times a real still results in a real number. The commutative property, the way I remember this, is that you can communicate in however you want. So a can be added to b, a talks to b, and then when you communicate, it goes back both ways. B communicates with a. Similarly, you can do a times b, which is the same thing as b times a. Associative property is how you group things. You can associate with whoever you want. So I can do a plus b and then add c to them, or I could have done b plus c and then add a to them. Same idea with multiplication. You can multiply two numbers together and then the third, or you can multiply a different two and then the other one that was left. Identity property. This is the property that says you can do something and never change it. So for adding, the magic number we add but never change anything is 0. But for multiplying, we multiply by 1 and never change it. Inverse property is how we undo things. So if I have a, and my goal is to do something to a to get back to 0, my identity, a plus negative a equals 0. So negative a is the identity for a. In multiplication, you're not trying to get to 0, you're trying to get to 1, because remember, up here, my identity was 1 for multiplication. So right here, I just want to work this one out because it's got fractions. A times 1 over a. This is a over 1 times 1 over a. And the a's can cancel off, and you're left with 1, which is what they got right here, the identity. The distributive property is that we distribute in. You guys see this one all the time. We distribute in. And the multiplication property of 0 means that when you multiply anything by 0, you always get 0. So we're going to use these properties to solve and evaluate some problems. So it says use the commutative and associative properties to simplify the expressions. So for this one, I'm going to regroup because I'm allowed to. This is called the associative property. Associate in whatever order you want. 6 plus 9 plus x is the same thing as doing 6 plus 9 first. So I get 15 plus x. This next one, we're going to multiply. I'm going to rewrite 16 as 16 over 1 and then y. So instead of doing the 16 times the y first, I'm really going to do the two fractions first. And I like to reduce my fraction. So instead of making it bigger, I'm going to make it smaller. Remember, you have to go across the fraction bar. So I'm going to put a 1 here because 8 goes into 8 one time. And right here, I'm going to put a 2 because 8 goes into 16 twice. So then I really have 5 over 1, which is just 5, times 2 over 1, which is just 2, times y. It's 5 times 2 times y, 10y. On this last one, we're going to write negative 10 over 1 times p times 6 over 5. So we can do multiplication and regroup it in the order that we want. So how about I call this negative 10 over 1 times 6 over 5 times p. And like I did earlier, I hate multiplying and then having to reduce. Like, why make things really big when you could just have them be smaller? So I can reduce this negative 10 to a negative 2 by dividing by 5. And then this 5 gets reduced down to a 1. So what I did was I divided by 5, negative 2, divided by 5. And because I did it top and bottom, everything stays the same and equivalent. So now on top I have this negative 2 times a 6, which makes a negative 12. On the bottom, I have a 1 times a 1, which is just a 1, times a p. So I can write this as negative 12p. Okay, so now the next examples want us to use the commutative and associative properties to simplify each expression, and we can also use the distributive property. So let's try doing the distributive property on the first one. So I can take this 3 and distribute it in. So I get 3x plus 3y, and then that's my final answer. On the next one, there's a negative 1. There's a negative 1 right there. I'm going to take the negative 1, I'm going to send it in and distribute it into both. So it should be negative 1m, and then a negative times a negative makes a positive 4n. On letter C, I'm going to do the distributive property in reverse, and I want to put up here distributive property. I feel like we're using that more here than associative and commutative. So here, I'm going to do the distributive property in reverse, which we also call factoring. I can pull a 7 out of both 7 and 21. So let me write this. This is 7p plus 7 times 3. Since both things have a 7, I'm going to pull that 7 out front, and then I'm left with a p plus a 3. So this is the distributive property in reverse. This one seems a little daunting. I know fractions are not your favorite, but we're going to do this. It's going to be okay. So we're going to distribute the 1/3 in to everything. So I get 1/3 times 4 fifths m minus 1/3 times 3 halves n minus 1/3 times, I'm going to rewrite this 27 as 27 over 1. So I'm going to reduce, if I can. The first fractions I can't reduce. On the second set, I can divide both by 3, so this is just a 1 and a 1. And on the third set of fractions, I can divide this by a 3 and get a 1, and this by a 3 and get a 3. No, not true. 27 divided by 3 is 9, sorry. Okay. Now when you do multiplication of fractions, we're going to go straight across. So 1 times 4 is 4. 3 times 5 is 15. M minus 1 times 1 is 1. 1 times 2 is 2. N minus 1 times 9 is 9 over 1, or just 9. And there is our final answer. Now we're going to look at absolute value. So the absolute value, by definition, is the distance a number is from 0 on a number line. So, for example, we have some number line, and here's 0. 1, 2, 3, maybe I call this one 3.8. This 3.8 is 3.8 units away from 0. Over here, -1, -2, how about -2.5? This, because we went to the left, we call it negative, but this thing's distance from 0 is 2.5. So the absolute value of -2.5 is 2.5. So let's try doing some examples. Okay. So the absolute value of -5/8, the negative's on the inside, so the distance that -5/8 is from 0 is 5/8 of a length away. Letter B is different because you're doing the absolute value of the inside, which is 8, and then the negative's on the outside, so we dropped on the negative, and so our final answer is -8. On letter C, we drop the negative on the outside, and on the inside, this piece right here, the absolute value of -2 is 2. So then I get -2 as my answer. For this one, we have to evaluate. X is pi. So I have the absolute value of 2, and instead of putting x, I'm going to put pi. Absolute value of 2 pi. Absolute value of 2 pi is just 2 pi. And so all of these black boxed items tell us the distance from 0 that the value inside the absolute value was, and then we account for on the outside some negatives. So next one says if P and Q are both numbers on a number line at coordinates A and B, respectively, the distance between them is one of two things, and they're equivalent. So I can do the absolute value of A minus B, or I can do the absolute value of B minus A. So let's say I have 2 points. Point P is at, on a number line, 3, and point Q is at 5. So here's 0, 1, 2, 3, 4, 5. Now we can count that these are 1, 2 units away, but let's make sure this formula actually works. So as I can subtract them either way. So I should be able to do absolute value of 5 minus 3, which is the absolute value of 2, which is 2. Or I could have done 3 minus 5, which is the absolute value of -2, which is also 2. So you can do it in either direction. Our next example is a word problem. And so it's talking about blood pressure and low blood pressure and high blood pressure. I'll give you a second to read it. So our blood pressure throughout the day changes. And what the question is asking about is PD, my pressure difference from normal. So my normal is 120. So some regular run-of-the-mill humans, blood pressure is 120. So if I want to find my differential, I need to plug in my blood pressure. So I have some patient whose blood pressure is 113. So I want to find their pressure differential. I'm going to do P, my pressure, minus what is normal, 120. In this case, my blood pressure is 113 minus 120. 113 minus 120 is the absolute value of negative 7, which is 7. So my pressure differential is 7, I'm guessing BPM is beats per minute, which probably is not atrocious. The run-of-the-mill human's heart rate is usually about 60 or so. Try some more absolute value. So I have some properties of absolute value. The absolute value of A is always going to be greater than or equal to 0. So either my distance from 0 is 0, or my distance from 0 on the number line is bigger than 0. But we always call that distance a positive number. It's never that I went to the left or the right. I'm just asking how far am I from 0. The absolute value of negative A is always equal to the absolute value of A. This one's like saying the absolute value of negative 6 is equal to the absolute value of 6. They both equal 6. An absolute value, we can either absolute value separately and multiply, or take the absolute value of the product. And the same idea here with division. I can take the absolute value of the top and the bottom, or divide the fraction and then absolute value. And then this one is called the triangle inequality, and it's used a lot in upper level math. And so what it's saying is, if you take two numbers A plus B and add them together, that is always less than or equal to the absolute value of taking the absolute value separately and then adding those two together. So let's try a couple more absolute value problems. Remember, on these ones we're plugging in, so I'm going to write out parentheses. So 2 times something minus 3 times something. So this should be negative 6 and 10. So I get absolute value of negative 12 minus 30, which is the absolute value of negative 42, which is 42. The next one is 2 times the absolute value of something minus 3 times something absolute value all over absolute value of something times something. So my x's are all negative 6. So I have negative 6, negative 6, 10, and 10, which will follow some PEMDAS. So I have to do some multiplication. So I have 2 times the absolute value of negative 6 minus absolute value of 30 over absolute value of negative 60. Sorry. So the absolute value right here, this piece right here, of negative 6 is 6. So on top I'm going to get 12 minus 30 over negative 60. 12 minus 30 is negative 18 over absolute value of negative 60 is 60. And then we can reduce this. I can divide both the top and the bottom by 6. So this is going to become, when I divide by 6, becomes a negative 3. And when I divide by 6, I get a 10. So my answer is negative 3 over 10. This one says find the distance between negative 5 and 8. So let's see. So earlier we proved, and we did a problem, I made up one that said I could do the absolute value of negative 5 minus 8. Or I could also do 8 minus negative 5. I'm going to start with the latter one because the minus makes a plus. So I get 8 plus 5. And 8 plus 5 is 13, and the absolute value of 13 is 13. Negative 5 minus 8 is a negative 13. Absolute value of negative 13 is 13. Is 13. And so these two things are here equivalent. And you could draw it and check. If I put 0 here, 1, 2, 3, 4, 5. So here's -5. 1, 2, 3, 4, 5, 6, 7, 8. Now we could count. So 1 unit, 2 unit, 3 units, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 13 units separating those two values.